Let's start from the first problem. Here we have to find the value of the sum of x and y provided an equation x squared plus 4x plus y squared minus 6y plus 13 equals to 0. So to solve this problem, we need to know a formula of a squared sum. So a squared sum of x and some number a equals to x squared plus 2ax plus a squared. Let's try to construct the squared sum with x from our initial equation. So according to the formula, we need x squared plus 2 multiplied by some constant a multiplied by x and plus a squared. So we don't know this a. But in the initial equation, we have x squared plus 4x. So to find this a right here, we need to divide this 4 by this 2. 4 divided by 2 equals to 2, so this is our constant. Plus a squared, so plus 2 squared or just 4. And since we added this 4, we also have to subtract it to change nothing in our equation. And this is our first squared sum. Let's also construct a squared sum but with y. Y squared plus 2 multiplied by some constant multiplied by y plus a squared. In our initial equation, we have y squared minus 6y. If we divide minus 6 by 2, we'll have minus 3, so this is our constant. Plus minus 3 squared, which is just 9. And we also subtract this 9. And in our equation, we also have plus 13, so do not forget about it. Equals 0. Now we can notice that we can get rid of the constants outside the brackets. We have minus 4, minus 9, which is minus 13, and plus this 13, so it's 0. So we have x squared plus 2 multiplied by 2x plus 4 plus y squared plus 2 multiplied by minus 3 multiplied by y plus 9 equals to 0. Now I can convert it into the sum of two squared sums. A squared sum of x and 2 and a square sum of y and minus 3. We can also notice that both summands are non-negative. First one and the second one, they both are greater or equal than 0. And we know that a sum of two non-negative terms equals 0 if and only if both terms are exactly 0. So we have a system x plus squared sum of x and 2 equals 0 and a squared sum of y and 3 equals 0. Which means that x plus 2 equals 0 and y minus 3 is equal to 0. Which gives us that x is equal to minus 2 and y is equal to 3. And now we can solve a problem as we are supposed to evaluate x plus y. X plus y here is minus 2 plus 3, which is just 1. And this is our answer. Okay, let's move to the next problem. Here we have some numbers a, b, and c that satisfy condition a divided by b divided by c equals to 2 divided by 3 divided by 15. Then we have several changes, like number A decreased by 10%, B increased by 20%, and C remains same. And the question is, by how many percent have their sum changed, the sum of these three numbers, A, B, and C? First of all, let's try to understand what are we supposed to find in this problem. So in the beginning of this problem, we have sum S0. S0 is the initial sum, just A plus B plus C without any changes. And this initial sum, it corresponds to 100%. And we also have delta. This delta is an absolute value of the difference between the sum after changes and our initial sum. And this delta, it corresponds to, let's say, y%. And we need to find this y using proportion. Okay, so how to do it? Before any changes, we have three numbers, A, B, and C. They satisfy a condition with a proportion that A divided by B divided by C equals to 2 divided by 3 divided by 15. One may say that, okay, let's just take numbers like A equals to 2, B equals 3, and C equals 15. Let's take just numbers from the task. And they will obviously satisfy the condition. However, if we multiply these numbers, for example, by 2, and take A equals 4, B equals 6, and C equals to 30, then these numbers will also satisfy the initial condition. And if we multiply this 2, 3, and 15 by any non-zero number, let's say x, then these numbers will all satisfy this condition for a given x, of course. So how we can rewrite this condition, how we can rewrite our A, B, and C, any arbitrary A, B, and C that satisfy this condition. We can say that A is just 2x, B is just 3x, and C equals 15x, where x is non-zero number. So from here we can find our S0, which is just a sum of A, B, and C. So it's 2x plus 3x plus 15x, which is 20x. Okay, then we have several changes. For example, our A decreased by 10%. Let's say that A after changes will denote it by A2, for example. A decreased by 10%, so it means that we have to take our initial A, then subtract from it. Why we have minus here? Because the number A decreased. So A minus 0.1 multiplied by our initial A. And this 0.1 is just 10 divided by 100. So it's our 10% of initial A. Let's substitute here A as 2x. So 2x multiplied by 1 minus 0.1. So it's 2 multiplied by 0.9 multiplied by x equals to 1.8x. Our b also changed. It increased. So we have b plus. It increased by 20%. So it's 20 divided by 100, which is 0.2 multiplied by our initial b. Let's also substitute our initial b here. So it's 3x multiplied by 1 plus 0.2 equals 3 multiplied by 1.2x equals 3.6x. And what's about our C? Our number C remains same. So C2 is just C equals 15x. And from here, we can find our sum after changes, which is just A2 plus P2 plus C2, which is equal to 1.8x plus 3.6x plus 15x, which is 20.4x. Now let's find our delta, which is once again the absolute value of the difference between sum after change and our initial sum. And this is 20.4x minus 20x, which is 0.4x. And now we can add numbers to here. So our S0 is just 20x. It corresponds to 100%. It corresponds to 100%. Our delta is 0.4x and it corresponds to y%. And from here we can find our y. So y is just 0.4x multiplied by 100 divided by 20x. So this is 0.4 multiplied by 5 equals to 2. And this is the answer. Okay, now let's move to the next problem. Here we have to compute the number of integers lying between the two roots of the following equation. Okay, so first of all, let's get rid of these 17. And also let's move these two terms to the left part of the equation. We'll have 2x squared plus 3x minus 2 multiplied by 11 minus 4 multiplied by square root of 7 minus 3 multiplied by square root of 7 minus 2 equals 0. Now let's open the brackets. 2x squared plus 3x minus 22 plus 8 square root of 7 minus 3 square roots of 7 plus 6 equals 0. Or 2x squared plus 3x minus 16 plus 5 multiplied by square root of 7 equals to 0. And this is our quadratic equation. The discriminant is 3 squared, which is 9, minus 4 multiplied by 2 multiplied by minus 16 plus 5 multiplied by square root of 7. Okay, equals 9 plus 8 multiplied by 16, which is 128, minus 40 multiplied by square root of 7 equals 137 minus 40 multiplied by square root of 7. And since we know that a square root of 7 is less than 3, since the square root of 7 is obviously less than a square root of 9, And this term here is less than 40 multiplied by 3, which equals 120. And this means that discriminant is greater than 0, so we have two real roots. Okay, and our roots are, so the first one is minus 3 plus the square root of our discriminant, 137 minus 40 square root of 7. And we also have to divide it by 2 multiplied by 2, so we have to divide it by 4. And we also have the second root, which is almost the same as the first one, but we need to change these plus to minus before the square root of our discriminant. So these are our roots. And the problem here is that we don't know the exact value of the square root of 7. But the good news is that we can approximate it. We know that the square root of 7 is somewhere between a square root of 4 and a square root of 9, which means that a square root of 7 is somewhere between 2 and 3. And to be more precise, we can say that a square root of 7 is slightly more than 2.5, as it is closer to the square root of 9. So the square root of 7 approximately equals to 2.6. So let's find x1, knowing that a square root of 2 or square root of 7 approximately equals to 2.6. So we have to change the square root of 7 here, minus 3 plus the square root of our discriminant, but we change the square root of 7 by 2.6. Yeah, and we also have to change here equality into the sign, which means approximately equal, and divided by 4. Okay, this is minus 3 plus square root of 137 minus 104, and we divide it by 4, which is minus 3 plus square root of 33 divided by 4. Okay, now we have another problem, since we don't know the exact value of the square root of 33, but we also can approximate it. The square root of 33 is somewhere between square root of 25 and a square root of 36. So our square root of 33 is between 5 and 6. And we also can say that a square root of 33 is somewhere closer to 6, due to the fact that 33 is closer to 36 than to 25. So we can say that square root of 33 approximately equals to, let's say, 5.7, which means that x1 approximately equals to minus 3 plus 5.7 divided by 4, which is 0.675. This is our first root, but we also have the second one. But it is simpler to find it, since we know everything about the first root. And we also understand that the first root and the second one, they differ only in the sign right here. So we have plus here and minus here, and everything else is the same. So what we can do with the second root, we can say that it's approximately equals to minus 3 minus 5.7 divided by 4. So I just use this result right here, but change this plus to minus. And this is minus 2.175. So what is the question of the problem? We are supposed to compute the number of integers lying between the two roots. Okay, so let's draw it on a line. So we have our first root somewhere here, which is 0.675. Our second root is somewhere here, minus 2.175. And we have several integers between these two roots. So the first one is minus 2 somewhere here. We also have minus 1 and 0. So there are three integers lying between these two roots. So the answer to this question is just 3. And this is our solution. Okay, let's move to the next problem. Here we have to determine the minimum integer value x such that the following function is defined. Okay, this task is pretty simple, since all we need to know is to solve the system of inequalities. The first inequality is that the fraction under the first square root have to be non-negative. And since we have a fraction here, we also need the denominator to be non-zero. So x minus 1 is not equal to 0. And we also have the second square root, the square root of x, which means that x also have to be non-negative. This is our system. And the system is very simple. We know that our x is non-zero or is non-negative, which means that the numerator in our first inequality is also non-negative. 3 plus x is also non-negative. So this last inequality guarantees that the numerator of the fraction in the first inequality is also non-negative. We need this one to be greater or equal than 0, this fraction to be greater or equal than 0, and we know that its numerator is greater or equal than 0, which means that we need the denominator to be strictly positive. We cannot set it to 0, so we need it to be positive. And this leads us to much more simpler system consisting only two inequalities. The first one is that x minus 1 is greater than 0, and the last one is that x is non-negative. The first inequality gives us that x is greater than 1, and the second one is still that x is non-negative, which means that the solution is that x have to be greater than 1. in our task, we have to determine the minimum integer value x such that the following function is defined. So we need minimum integer. X has to be strictly greater than 1. So we cannot take 1 here as an answer. So we need to take the next integer number, which is 2. So the answer to this problem is 2. Okay, let's move to the next problem. Here we know the area of the equilateral triangle, and we have to compute the length of its bisector. Okay, let's remind some properties of the equilateral triangle. So the first one is obvious that the length of all sides is the same. Let's say that it's some number A. The next one is that the angle between each two sides is also angles between these two sides are also the same. This is 60 degrees. This one is also 60 degrees, and this angle is also of 60 degrees. What is next is that in equilateral triangle, all bisectors are the same, and what is more, they also coincide with the heights. So we have a bisector BH here, which is also the height. And if we find this h here, then we'll solve the problem. Okay, in the problem, in the task, we also are given the area of this triangle. So how can we use this information? We know several formulas that can help us to find the area. The first one is that our area is 1/2 multiplied by A multiplied by h, where h is the length of heights. And there is a second formula. We also need 1/2. Then we multiply the length of one side by the length of another side. But in our equilateral triangle, all sides are the same, so we'll always have the multiplication of two a's here, and multiply it by sine of alpha, where alpha is the angle between these two sides. For example, if we take this side and this side, then we need the angle BAC. And in our triangle, as we said before, all these angles are of 60 degrees. And we know that it equals 16 multiplied by square root of 3 divided by 3. Okay, so from here we can find our A. And if we use this and substitute A, then we can find our H. So 1/2 multiplied by A squared multiplied by the sine, which is just square root of 3 divided by 2, equals 16 square root of 3 divided by 3. Let's just divide it by square root of 3. And we are left with 1/4 a squared equals to 16 multiplied by 1/3. We can multiply it by 4, which will give us a squared equals 4 multiplied by 16 divided by 3, which means that A is 2 multiplied by 4 divided by a square root of 3, which is 8 divided by a square root of 3. One may say that, okay, but we have two solutions here. We have two A's. Yes, we have two A's. The first one is positive, the second one is negative. But since uh, we need the length, so A is the length of a side of this triangle, then we are interested only in positive solution. Okay, now we have our A, and we can substitute it right here to find H. 1 over 2 multiplied by A, which is 8 divided by square root of 3, multiplied by H, equals to this 16 square root of 3 divided by 3. Okay, let's multiply it by square root of 3, then we'll get 4h equals 16 multiplied by 3 divided by 3, which is just 16, which gives us h that is equal to 4. And this is the answer to our problem. Let's move to the next task. Here we have to determine the maximum positive integer a such that the following system of equations has strictly less than 4 solutions. Let's focus on the first equality. Sine x plus y equals 0 if and only if its argument, which is x plus y, equals pi multiplied by k, where k is some integer number. We can express y from here. So from here, y is minus x plus pi k, where k is still integer, which gives us straight lines, a lot of straight lines. Okay, the second one gives us, so it's like x squared plus y squared equals a squared, and this gives us a circle that is centered at point 0, 0 and has a radius a. So by changing a, we can control the radius of our circle. And by changing the radius, we'll change the number of solutions. I have a picture here. Let's try to understand how it works. First of all, let's say that we set our a equals to 0. In this case, we have a trivial solution that is just a point 0, 0, and it gives us only one solution, this particular point. By solutions here, I mean the intersection of our circle and these green straight lines. Here we have one intersection. This is one solution. Let's increase the radius. Increase A by a little bit, and we'll have this purple circle. We see that there are two solutions here, this one and this one. We can also change it by some small positive number, and we will still have two solutions. And we will have these two solutions until the moment when our circle reaches these two lines, this one and this one. This is our red circle, and you can see that here we have not two, but already four solutions. We have four solutions. If we increase A, then we'll have more than four solutions. For example, if you focus on the blue circle, then you may see that we have 1, 2, 3, 4, 5, 6 solutions here. We can increase A and get even more solutions. But here we are interested in less than four solutions. So we have less than four solutions until this red circle right here. So let's focus on this particular triangle and find the radius A that corresponds to this red circle. So where do we have our radius here? This one is A. Okay, so this is our rectangular triangle. This is A, C, B, and this point is H. Okay, and we want to find our A from here. Let's focus on the triangle ABC. As I said previously, this one is rectangular, so AB squared equals AC squared plus CB squared. And from the graph we may see that AC equals CB equals to pi. Since this point is pi and this one is also pi. So we have two equal sides, this one and this one. Which means that AB squared is just pi squared plus pi squared, which is 2 pi squared. Consequently, AB is equal to square root of 2 multiplied by pi. We still want this solution to be positive. This side is equal to square root of 2 multiplied by pi. Okay. We also know that AC equals to CB, which means that our CH here is not only a height, it's also a median. So these two sides have the same length. AH equals HB. And this is equal to half of AB. So this is just square root of 2 divided by 2 multiplied by pi, which is 1 divided by square root of 2 pi. Now let's focus on one of the smaller triangles, for example, ACH. We know that this side AH is 1 divided by square root of 2 pi. And we want to find A from the triangle ACH, which is also rectangular. AC squared equals AH squared plus CH squared. So pi squared is equal to 1 divided by square root of 2 pi, and we want it to be squared plus A squared. So from here we have that A squared is 1 over 2 pi squared. We still want A to be positive, so A is 1 over square root of 2 pi. which approximately equals to 2.2. So what do we need to find in this problem? We have to determine the maximum positive integer such that the following system of equations has less than 4 solutions. As we said before, this red circle is the first circle, so it's the circle with the smaller radius, with which we have less or equal or more or equal than 4 solutions. So if A is less, strictly less, than this number 2.2, then we have less than 4 solutions. We have 1 or 2. Okay, and we need to find maximum positive integer. So the maximum positive integer here is just 2. Once again, we need maximum positive integer such that A is less than this number. And this is the solution of this problem.